In 2008, the global economy lost $2 trillion in a single week. Economists didn't see it coming, but physicists did because they were watching entropy. Economies are treated like abstract systems: supply, demand, rational actors. But there's a problem. They're physical systems. They run on energy, and energy has rules. The second law of thermodynamics says that in any closed system, entropy, or disorder, always increases. This isn't philosophy, it's physics. And it applies to economies too. Here's what that means. When you burn gasoline in a car, only 30% becomes motion. The rest? Heat, waste, disorder. You can't reverse it. You can't get that energy back. Economies work the same way. Every factory, every computer, every transaction requires energy input, and every process generates waste heat. The more complex the economy, the more energy it dissipates. In the 1980s, physicist Robert Ayres asked, "What if we model economies not as money flows, but as energy flows?" He analyzed 150 years of U.S. data and found something stunning. GDP growth tracks energy consumption almost perfectly, not money supply, not interest rates, energy. Because economic work is literally thermodynamic work. But here's where it gets interesting. Economists measure growth. Physicists measure efficiency. And there's a hard limit, the Carnot efficiency. No heat engine can ever be 100% efficient, ever. This creates a paradox. To grow, economies need more energy. But energy systems have maximum efficiency. So growth requires either more energy input or system collapse. In 2007, total credit in the U.S. financial system was expanding faster than energy productivity. Banks were creating economic growth without physical work. The entropy kept building. There's a principle in physics called maximum entropy production. Complex systems naturally evolve to dissipate energy as fast as possible. Rivers branch, lightning spreads, and economies financialize. When financial instruments multiply faster than energy infrastructure, the system maximizes short-term entropy production. It feels like growth, but it's thermodynamic instability. Economist Steve Keen incorporated energy into his debt deflation model. His prediction in 2005: the U.S. would hit a debt-to-GDP tipping point around 2008. He was right. The collapse wasn't random. It was thermodynamically inevitable. The system had maximized complexity without increasing energy throughput. Entropy found equilibrium through crisis. Today, physicists at the Santa Fe Institute are building thermodynamic models of global trade. They found that economic fragility increases when energy networks become over-centralized. The European energy crisis in 2022? Thermodynamic shock. When Russia cut gas supplies, the continent's economic entropy spiked instantly. Prices followed the second law, not supply and demand. Here's the prediction. Economies that decouple GDP from energy use through efficiency, gains will stabilize. Those that rely on financialization will cycle through crises. It's not economics, it's thermodynamics. This changes everything. Climate policy isn't just environmental, it's economic stability. Energy infrastructure isn't just practical, it's existential. The laws of physics don't negotiate. Economists model human behavior. Physicists model energy behavior. The difference? Energy doesn't care about your incentives. Entropy always wins. The next economic crisis won't be predicted by markets. It'll be predicted by the laws of thermodynamics. Because in the end, we're all living in a heat engine.